All right, everyone, welcome to problem number 12. So, in the figure, it is given that C is a right angle, D is the midpoint of A and B, meaning it divides them into equivalent segments, right? DE is perpendicular to AB, AC is equal to 8, and CB is equal to 10. So what is the area of quadrilateral ADEC? What is the area? So, first glance at this problem, you might think, okay, area of a quadrilateral, that's not that hard. But, you look at it closer and you're like, oh, that is not like any quadrilateral I've ever seen. So you can't just go with a simple area formula. Oh well. But, if you look at the picture as a whole, you might notice something. You see the quadrilateral is contained within a right triangle, right? ACB, that's a right triangle. And you might also notice EDB is another right triangle, a smaller right triangle. And if you know about area, you might think, oh, the area of the large triangle minus the area of the small triangle is the area of the quadrilateral. So that's what we want, that's what we can find out, and that's what we're going to get. So here we go. We know these two side lengths, so with that we can find both the area of triangle ACB and the length of AB, the hypotenuse. So let's find the area of the large triangle first, our step one. So if we want area of ACB, area of a right triangle, 1/2 base times height, so 1/2, 8 times 10, and that is 80 over 2, or 40. All right, step one done. Now the hypotenuse, if you're familiar with the Pythagorean theorem, you know base squared plus height squared equals hypotenuse squared, so let's do that real quick. 8 squared plus 10 squared is equal to AB squared. All right, so root 164, skipped a couple steps there, sorry if that disoriented you, but gotta move it along, equals AB. And you look at this root, it looks kind of weird, like no root you've ever seen, but that's all right, because if you think about what factors go into it, 4 and 41 would go into that, right? I think so, if my math is correct. So AB is also equal to root 4 times root 41, or 2 times root 41. And that's nicer to deal with, isn't it? All right. So that's the length of AB, and because D is the midpoint of AB, like I said, AD would be equal to DB. So 2 root 41 divided by 2 is just root 41. So AD, root 41, and DB, another root 41. That's lovely. All right. So now we know the hypotenuse and also the length of DB. And how is that helpful? Well, I'll tell you something. Using geometry here, you might notice, hey, this is a right angle, and this is a right angle. Another thing these two triangles have in common is they share this angle B. And if you remember something called the angle-angle theorem, if two triangles have the same measure for two angles, they also have the same measure for their third angle, and that means they're similar triangles. Who cares, right? What can we do with that? Well, we can figure out the length of DE, of course, that's the base and that we need in the area formula, by just setting up a proportion. Just set the base of ACB over the height of ACB and set that equal to the base over the height of EDB. So let's do that. So we get 8 over 10, base over height for the large triangle, is equal to base, that's the one we don't know, I'm trying to solve for, DE over DB, the height, root 41. I'm just going to simplify this. 8 over 10 is 4 over 5. Cross multiply, and we get 5 times DE equals 4 root 41. Or DE equals 4 root 41 over 5. And that is the length of DE. All right, so our step 2, area of the smaller triangle, area of EDB, It's another right triangle, 1/2 base, which we just found, 4 root 41 over 5. I hope we're getting all this. Times the height, EDV, root 41. Or root 41 over 1. And that may look kind of strange, but actually that's pretty great, because you got a 4 over 2, that's just 2. And you got a root 41 times root 41, and that's 41. So this is equal to 2 times 41 over 5. Don't forget that. And that's the same as 82 over 5. Again, looks strange. It's not. It's correct, at least from my knowledge, that's correct. So, area of ACB, we have that. And we subtract area of EDV to get the area of our quadrilateral, and that's what we're looking for. EDV. And that would be 40, right? Where is it? There it is, 40. Minus 82 over 5. Also 200 over 5, right? If we're converting 40 into a fraction, minus 82 over 5. All right, running out of room here. Let's write it down here. 200 minus 82, 118 over 5. And don't forget your units in there. Units, because we're not told what units we have. Units squared. And that is our remaining area. That is the area of quadrilateral ADEC. Wow, what a ride, right? All right, so there you have it. Take one last look over it, and that was fun. Make sure you have fun.